math class, and your teacher comes up with this equation and asks you to solve for x in this equation. Commonly, when we have polynomials, we could simply uh, subtract and add or multiply, divide, uh, get the square root, or raise to a certain uh, power. But here, this is not as easy. So first, I encourage you to try to solve it by yourself. You can pause the video if you want to give it a shot. Now, I'll solve it uh, by myself so you can see how this is solved. First, I want to introduce to you my friend, the Lambert W function, or rather, the omega function. It's a W, but it's also an omega function. And how does this function look? Well, first, imagine this function, which is f of x is equal to x times e to the x. Well, this is not Lambert's function. Rather, this is the inverse of Lambert's function. But since in this case you can't simply isolate for x, we come up with the function w, and we say that w is the inverse function of this one over here. So to make this more accurate, instead of x, we want this to be w. And if we were to get the inverse function of this, we will get that w is equal to the inverse function of w e to w. And as you can see, this is just w. But commonly, instead of saying f of minus 1 of this, we use w itself to denote the Lambert's omega function. For example, we could say Lambert of, who knows, 2 times e to the power of 2 is equal to 2. Uh, Omega of, let's say, uh, natural logarithm of 2 times e to natural logarithm of 2 is equal to natural logarithm of 2. And now, what can we do with this information in order to solve the original equation that we were talking about? First, we want to get something of the form x times e to the x. It doesn't have to be x necessarily. It's just something that resembles this. So what I'm going to do is first look at this 2 to the x. This is not e to the x, but it's something similar. And we can rewrite 2 to the x as e to the natural logarithm of 2 times x. I'm going to write x before natural logarithm of 2. and then we keep the rest of the equation as is. Now, we don't have anything multiplying e to the x natural logarithm of 2. And also, this x is kind of in the void. So let's move it to the other side of the equation. So subtract x on both sides of the equation, and we will get e to the x natural logarithm of 2 plus 0 is equal to 5 minus 6. And we are left with e to the x natural logarithm of 2 is equal to 5 minus 6. This is, you might think that this is messier than it was before, but actually this will help us. Why? Uh, Now let's divide both sides by e to the x natural logarithm of 2. So let's do that. E to x natural logarithm of 2 is equal to 5 minus x divided by e times x natural logarithm of 2. And these two will cancel out. And I want to express this in form of a negative power. So this is going to be 1 is equal to, in braces, x minus x times e to minus x natural logarithm of 2. And this is now getting form because here we have minus x and minus x, but this, in order to get the omega function from here, we need the thing that is in the exponent and the thing that this is multiplied by to be the same. But minus x natural logarithm of 2 is not equal to 5 minus x. So what can we do now? Well, I suggest that we, in order to get this 5 over here, we multiply this by e to the power of 5 natural logarithm of 2. Why? Because by why by natural logarithm of 2? Because here we have natural logarithm of 2 as well. So we will be able to get natural logarithm of 2 out as a common factor, and we are going to get 5 minus 6. But since we multiplied by to the 5 times natural logarithm of 2 on the right hand side of the equation, we also need to multiply by the same amount on the left hand side. So this is e times 5, I mean to power of 5 natural logarithm of 2. Now we can simply add up these two, the powers, the exponents of these two powers, and the equation is going to be simplified as follows. E to the 5 natural logarithm of 2 is equal to 5 minus x times e. I'm going to put this 5 in front of the x, and 5 natural logarithm of 2 minus x natural logarithm of 2. And as I said, we can get out this natural logarithm of 2. And also first, I'm going to simplify this as 2 to the 5, because e to the natural logarithm of 2 is just 2. And this is raised to the power of 5. And 2 to the 5 is nothing but 32. Now, On the right hand side, we got 5 minus x times e to the power of, we get natural logarithm of 2 out times 5 minus x. And we are almost there. As you can see, we are closer to something that resembles a times e to the a in order to get the argument itself. But here we are missing natural logarithm of 2 on this part, because here we have natural logarithm sorry, here we have natural logarithm of 2 times 5 minus x. But here we only have 5 minus x, so we are going to multiply both sides by natural logarithm of 2. Now I'm going to move this a little bit to the right, or better, all these a little bit to the right, and we can now multiply by natural logarithm of 2 on both sides. Natural logarithm of 2. And we can already get the omega function on both sides. So if we get omega on both sides, we are going to get omega of natural logarithm of 2. Actually, I want to put the 32 before natural logarithm of 2 is equal to omega of natural logarithm of 2 times 5 minus x times e to natural logarithm of 2 times 5 minus x. But here we have something times e to that something. So this is nothing but that something. So this is natural logarithm of 2 times 5 minus x. Because remember that Lambert W function is the inverse function of this one over here. So that's why I can say that this is equal to this. And on the left hand side, we simply have omega of 32 natural logarithm of 2. Now, we want to solve for x, which is what we were looking for in the first place. So let's divide by natural logarithm of 2 on both sides. And these two are going to cancel out. So we are left with 5 minus x is equal to omega of 32 natural logarithm of 2 divided by natural logarithm of 2. So let me make this bigger. And now we can add x on both sides, and we're going to get x plus omega natural logarithm of 30 omega 32 times natural logarithm of 2 over natural logarithm of 2 is equal to 5. And this was only to make x positive, but now we are going to subtract this from both sides of the equation. So x is equal to 5 minus omega of 32 times natural logarithm of 2 divided by natural logarithm of 2. And wait, but now we have to know what this is. How can I know what the exact value of x is? Well, in this case, you need to use numerical methods. Uh, you could use Newton-Raphson's method in order to approach this amount over here. But if you want something more simple, you can simply use this method by using omega function. And this is the solution to our original equation. 2 to the x plus x is equal to 5. Well, I hope that you like this video. So, see you guys.